and we are going to start our topic. And yesterday, remember, we started to discuss about stack. Okay, and what we will discuss here is the stack is going to be implemented as it implemented in array. Okay, that's our goal, is it? And for stack, do you still remember the two most important operations for stack? Two important operations in stack.
Pop and push.
Yeah, very good. Operations is push, is it? Push an item, is it? And pop, is it? An item. So push is for what? Is add a new item. Where we add? At the top, is it? And the pop is what? Is you remove top item, is it? So those two important operations we use a lot in stack, okay? And generally speaking, for stack, what do we care about? It's if we draw the UML diagram when we design the stack class. Okay. So yesterday we discussed is that we are going to have the array. Is it? And the type is going to be integer, is it? Because we are going to consider integer stack. And we have the index. Is it integer? And we have constructor for stack. Constructor, is it? And then we have push operation, and we have pop operation, is it? And generally speaking, we also interested if the stack is empty, is it? And later on, we may add some other we also have top operation. Top is to retrieve the top item. Is it? And if top is used to retrieve the top item, so what do you think push? Is push get or set function? Push belongs to set or belongs to get method. Because in class we said, generally speaking, you have accessor. Is it? Accessors means get method. And we have mutators, mutator set method. Is there someone replying chat? Is it? And say set, yeah, very good, okay. So push is set function, as it belongs to set category. And the pop also belongs to set category. Then how about top? Do you think top also belongs to set or get? So it should be what? It should be get category, is it? And if it's get, what do you think the return type for top should be? In this case. Let's see. Yeah, integer, very good, okay. So the return type should be integer. So that's the UML diagram for stack class. And the next, let's see, how do we implement? Is it? So we are going to have the array. Is it? So let's see. I'm trying to explain the concept behind it, and later on we will understand. Is it? So suppose our array capacity is 5. Okay, for our M array. Okay, the capacity is 5, is it? And so basically you can only have 5 slots. Is it sub 0, sub 1, sub 2, sub 3, and sub 4. Is it? That's represent. Is it? Okay. And the M top. And yesterday we said we initialize it to -1. Okay. Initialized to -1. Is it? So M top initially is at -1 at this time. Is it your M array? So this is at M array. Is it? It's empty. Is it? No numbers. No numbers yet. Is it? But is this M array in heap yet or not? So you must already allocate space in heap for it. Okay, so remember this, because whenever you want to use array, you need to new first. Is it? Okay, so we are going to discuss that push operation. Is it? And the push, yesterday we discussed it should be a void method. Is it? And you are going to add a item. That item should be integer. As it should be integer. Okay, so suppose the first number you add is what? Is 100. When we add 100, what M top should be? M top should be updated to what? To 0. Is it? So it's what? It's +1. Is it? And at this time, your M array sub 0 is 100. Is it? That's what happened. And then I add 200. After I add 200, what's happened? The M top is going to be what? Updated to 1. Is it? And your M array sub 1 is going to be 200. Is it? And then you can add 300. Is it? You add 300, then M top updated to what? To 2. Is it? And the array updated to what? To 300. Is it? And then 400. Is it? Then top is going to be updated to 3. Is it? Then your array sub 3 is going to be 400. Is it? And then you can add 500. Is it? Then M top is going to be updated to 4. Is it? And let me change the color. Okay. And then in this case, then that M array is going to be updated to 500. Is it? Now can I add 600? Can I add 600?
No.
Yeah, very good. Yeah, you cannot. Okay, because what? Because array capacity is 5. Is if you want to add, you cannot do M array sub 5. Is it? This will tell you what? Array out of index error. Is it? Exception. Is it? We learn exception. Is it? So you cannot. Is it? So you cannot. So in this case, the stack full condition in this case is what? Is your top index. Is it? Top index, when top index is already what? Suppose we call the array capacity as capacity. Some instant. Is it? It should be capacity -1. Is it? That's the full condition. What is the stack empty condition? Is what? Is -1. Is it? Top index is -1. Is it? Okay, so now you know how to write push operation. Is it? You can kind of guessing how to do push operation. Is it? You need to update the top index. Is it? But you need to make sure your stack is not full. is it? And then what? Then your M array, is it? M top is going to be assigned to that item, is it? And we need to also deal with error situation, is it? So that's the general idea about how to implement push operation, is it? And next, let's see then how do we do pop, is it? Pop operation. So pop is you're going to remove the top, is it? But to remove the top, it's kind of you want to get rid of the 500, is it? 500, but in array, just let's see. Is there a way I can wipe this out? I have no way to wipe this guy out, is it, from heap? I cannot. So the only way is what? But I can make my top index point to this 400. So that 500 is basically not in stack, but it's still in array. Is it? That 500 is not gone. Okay, that M array sub 4 still hold 500, but your top index change. Is it? Your top index decrement by 1. Is it? Decrease to 3. Is it? So then you are going to remove 400. You remove 400, this array element you cannot remove. You cannot remove it, is it? But what? You can change the top index to 2. Is it? So that, okay, people will know, okay, your stack then will only have this 300 or this 3 number, but your array still have those 5 numbers. Okay, so here be careful. And then based on what we just described, is it? So for pop operation, is it? What you can do is you just decrement the top index, is it? But to make sure it's not empty, is it? Your stack shouldn't be empty, okay? So that's how you are going to deal with pop, okay? So basically, over here, you kind of understand how push and pop works, okay? So next, let's take a look at our coding. Okay, so here we have, we define, so over here, what I did is I define a public class called the integer stack. Okay, stack integer, is it? And it implements clonable. What is clonable? Is clonable a class? Concrete class? Abstract class? Or interface? Or some other thing? What is it? Okay, let's see what the answer is. Okay, yeah, interface, very good. Okay, very good. Okay, clonable is an interface, is it? It's an interface. Okay, then next, let's see. We discussed the stack class is a previous. So we have instance variable array and the top index. Array is an integer, is it? And this top index. And over here, we define the capacity, is it? This is a constant. Constant, so it's static and final, okay? Because once you define final, you cannot change it, is it? And stack means it's independent of instance, it belongs to the class, is it? Okay, we understand of those concepts. Okay, this stack int, what is this? Who still remember it? Okay, how about this is our first quiz question. quiz question. What is this? Public stack int. You can send it to my chat, okay? What do we call this? Who still remember before when we learn class? Is it? We learn class. What the method class has? Class, generally speaking, it needs what? Need a constructor, is it? And a getter and a setter, is it? And some other functions. Is this generally speaking a class need a constructor? Is it? What does constructor do? Constructor is to create an instance, is it, with initialized value of its instance variable. Okay, so can you send it to chat our first question? This
would be
stack.
a default constructor, right?
Yeah, very good. It's a default constructor. Yeah, it's a default constructor. Very good. Yeah, you can. And not everyone send your answer to the chat. We only have three answer. So please send your answer to the chat, okay? And what this constructor does, it create the array. As its capacity is 8, and initialize top to -1. So that's what this constructor does, okay? So hopefully we understand all of the code here. And then next, let's see. Oh. Next, then we have the second constructor. This is second, and this constructor, the parameter is what? Parameter is an array. Is it? And so what over here we are trying to do is we are going to create a stack with whatever the array plugged in. Is it? Okay, so it's going to create the array. Is it? And it's going to have the top as the array's size -1. Okay, it's going to initialize this top. And then over here, you're going to assign each element, is it, from the plug-in array to stacks array, is it? But we place this in a try-catch block, is it? Because it involves array, it may have array index out of bound exception, is it? Previously, we learned that, is it? So it's unchecked exception, is it? And then if that happens, you bring your top index back to capacity -1, because that means the array size. So this means this P array size is larger, is it, than capacity, is it? And of course, in this case, your array is already full, so you cannot take any more. So you just say, okay, stack is full, okay? Okay, so here, let me ask you another question. Why I did so many of this, is it, and then do element by element copy? Why don't I just do M array equals P array? That's much simpler, is it? Why don't I just do this? Anyone knows the answer?
It doesn't work. They will point to same memory location.
Yeah, very
Just
good.
reference.
Yeah, very good. Okay, so this will cause the shallow copy issue. Is it? You don't want to do that. Is it? So that's why over here you let your array has its own memory location. Is it? And then you just do value copy. Is it? So this is a deep copy. Is it deep copy? Okay, and so this is our second quiz question. Second quiz question. Okay, so you just say, we are not going to directly assign, is it? So we call new to create M array, is it? So in this implementation, we do deep copy. So you just answer the second question is, for the second constructor, we do deep copy. So that's the answer. So the second constructor did deep copy. Okay, second constructor did deep copy. Okay, so please send your answer to the chat. So second constructor did deep copy. Okay, so that's the answer. And then next, let's see. The empty. Empty condition is pretty simple to check. Just check if top index is -1, is it? Okay, then push. As a push, like we said, you're going to add some new item, is it? And the return type is void. You're going to implement the top index, is it? And then you assign the new item to top index, is it? But over here, we also have the try-catch block. If the stack is full, is it? If stack is full, you cannot do that, is it? You need to reverse back your top index, is it? So this push is also not too comprehensive. And then the pop, is it? And for pop, it just said, okay, if the stack is already empty, is it? So here is stack empty, is it? If stack is empty, of course, you can throw exception, is it? Otherwise, you can just decrement top, is it? Basically, you can see inside the pop. So inside the pop, is it? No operations on array, is it? We just do everything on the top index, is it? Okay, that's pop. Then next, let's see the top, okay. And the top is try to return the top item, is it? But of course, it's your top index. If your stack is already empty, you have nothing to retrieve, is it? That's why over here it says I'm going to throw an exception. So this method throws this exception. And over here to throw exception, here's a throws exception, okay? And then next is the toString method. So override, is it? And oh, this override who? Which class? Because override can be applied to what kind of scenario? As if you have superclass, is it? Superclass, is it? And what? Interface method. Is it someone answered? Is it? Let's see. Override, yeah, override object, very good. Yeah, very good. Okay, so over here, this is object class. Is it? toString. Okay, so what we are trying to do, if the stack is empty, you just say, okay, stack is empty. Otherwise, what we are going to output is top down. Okay, top down, because we are going to output from the top to down, is it? And we are just going to concatenate the string, okay? And more efficient, we should use the string builder, is it? But here we just try to simplify everything, okay? So that is for toString, not too much, is it? And then over here, we said we override clone. So where is this clone method come from? So where does it come from? Do you still remember? And this come from, we implement clonable interface, but this clone method itself, it's also from object, Okay, be careful, okay? That clonable, it's not a clonable interface, okay? So it's the clone method, okay? Clonable interface, you remember we said it's a kind of special, is it, interface. So it's kind of serves as a marker interface. Marker interface, so that whenever you implement that, then you know you're going to implement this clone method. But this clone method comes from object class. Okay, be careful the concept here. So what we want to do a deep copy is this. So that's why over here you first create a new object of the stack. Is it? And then you just going to do the copy of index, copy of the index, and the copy of the array. Is it? So here is arrays clone method. And the arrays clone method, it's going to do what? It's going to be a deep copy. Okay, deep copy. And here we can directly do this. That will work because here, this M array type is integer. Is it? And integer is what? Is a primitive type. So if you just call clone, arrays clone, it will fulfill the objective. Okay, and if your array is some other reference type, then if you just call clone, that won't work, okay? Because that involves the internal elements need to refer to somewhere else. Is it because over here, this is a heap? Is it heap? Is it? And you have that M array. M array, is it? Array, is it? And it has suppose 100, 200, is it something? Is it? And then you call clone, is it? And it will create a copy, is it? And then do 100, 200, element by element. That's because it's primitive, is it? But you remember previously we also learned, so be careful, okay? And then this won't work, okay? So if your M array, is it? And here suppose it's car1, car2, some car objects, is it? And here is car1, is it? And here is car2, is it? So that's going to reference to another memory. And if you just call M array dot clone, that won't work. You remember the internal, as it's still going to reference to the, then you need to do another deep car1 clone as that copy, okay? So that's another topic, and previously we know that, okay? So anyway, if your array over here, because our array type is primitive, so if you call clone, this is real deep copy. So that works, okay? Otherwise, if array is reference type, then we need to be careful, okay, about aliasing problem. Okay, so that's the idea about this array, not array, this stack, is it? And next, let's see the,
Hey, I
yeah,
have a
please.
question.
Uh-huh.
So
Oh,
can
you
you
have
go
a question?
back?
Let me get back, yeah. Yeah. Oh, okay.
So we have two clone methods, right? The overrided and the one we use over here, like array.clone, right?
Array.clone. Yeah, we have two clone method. Yeah, here you mean.
So the one
This
we
is,
use exactly in the method is clonable interface method. Which method is it?
Sorry, I didn't quite get your question. So this clone method is our stack int classes instance method. Instance method. Okay, and this is arrays method. So this is called arrays clone method. So
Oh,
array
makes
is,
sense.
yeah. And over here you need to override it. Okay, you need to, because you are going to create an object first. Okay, very good question. So maybe let me draw it, will make more sense. Okay. So here in your stack, or not stack, in heap, is it? So you have a stack object created, is it? So suppose we call this stack 1. Is it? Stack 1 basically it has that M array. Is it? So it has that M array. That M array basically is going to point to somewhere in the heap. Is it? And so, and over here you call stack.clone. Is it stack.clone? So it's going to create the clone. Is it? This is a clone. So stack 1 clone. Is it? And it also has that M array. Is it? And its M array in this case, you're going to get, you call arrays.clone. Is it? So you're going to have, is it created? And it's going to point to this array instead of the other one. Is it? Because if you don't, if you cross this part out, then you won't have this. Then this guy also going to point to that array. Okay, even though you think, oh, I create a clone, is it? But you see, it's still referred to the other array. You don't want that to happen. You want a deep copy, is it? So that's why you call the clone. So it the array has.
Sorry, my question was that we just have 2 clone methods, and I was confused. Like, is it recursion or what? Like, because
no, this has nothing.
Recursion, so we use
No, this has nothing.
array.clone.
No, this has nothing to do with recursive, because like I explained, this clone is clone the array, like I draw here. That makes sense?
Yeah, thank you.
It's clone this. It's regarding this two, is it? And this clone is here. It's regarding this container. Is it? You create another container. That makes sense now?
Yes, yeah, thank you.
Yeah, this makes another container, but the container inside container, you have some arrow. Is it? That arrow point to some other memory location. Okay, so that arrow point here, and this arrow point to here. That makes sense? A very good question. Okay, and then it returns this. So this is what it returned. Is ST. Okay, this is that ST. That makes sense now? Clear?
Yeah, it does. Like, yeah, thank you.
Okay. Yeah, very good. Okay, very good question. Yeah, deep thinking. Okay, and then let's take a look at the application. Okay, can I? No, I need to stop first. Bring back to. Why? Okay, then next, let's see over here. Okay, very simple application for the first case, is it? So whenever you want to create with our stack integer, that class we created, is it? Over here, you have that variable. Is it? Then you call new stack int, call constructor, is it? To create an object of integer stack. Is it? So basically, you have this container, is it created? Okay, and here is the array, is it? Nothing new. And then we loop through the array. We are going to add each number to this stack, is it? So you have 29, 51, 308, 65, 155, 78, 81, 99, is it? So this is our array, is it? This is our array. And how many? We have 8, is it? And you remember this array capacity is 8, is it? So it's full, is it? So it's full. So if you wanted to add 1,000, you will see the exception will be thrown. Is it? Exception will be thrown. Okay, and we can also call output, is it? And over here it's a call, it's toString method, is it? Stack int, it has that toString method, is it? So that's how this part work, okay? And then next, let's see. Over here, then I call clone, is it? So let's see here. So you remember our stack integer, we have the clone method, is it? And this is the second stack int variable. And what do we call this? Do you still remember parentheses and then the name of the class ahead of this first int stack dot clone? Why do we need this? Why do we need the parentheses and the stack int? Who still remembers? What do we call it? Clone return type is what? Clone return type.
Object.
Somewhere. Yeah, very good. It's object. Is it? It's object. Okay. And the variable type is what? Is stack int. Is it? So that's why over here we cast it. Is it? So this is our third question. Okay. So we cast the clone. Clone, is it clone method's return type to stack integer? Okay, so your answer is just casting. Okay, that's called casting. And then we can pop an item from the clone, is it? And then we check our original stack. You will find it's not modified, is it? It's not. Oh, I'm sorry, this is third quiz question. So please answer. So it's your answer is cast. Okay, casting. Okay, so that's this part. And then let's move on. So next, what do we have is we have an integer array. Is it integer array? And what this integer array will have is you're going to keep so initially we have that array, is it 28 or something, is it of the 8 numbers, is it? Then you are going to, so here is our int array 2, is it? The first number is going to be the very top number, is it? The top number going to go to the first, sub-0, is it? And then you pop. You remove it, is it? And then to reach the second one, is it? And it's going to get it to the second and keep doing it until the last one, 28, the sub-7, is it? So that's what this array, is it? So basically, the array hold what? Why my pen not working? So basically over here, your array will hold what? Hold reversing items. Is it from stack? Is it? It's top down. Is it top down numbers? Is it? So that's what this int array 2 hold. Okay. Okay, then next, let's see the next part. What the next part shows is, then you can check if the stack is empty. Is it? After it's empty, you can try to do top to see if it works. Is it? And then we can also output that integer array. As you will see, it's a reverse of the original array. Okay, so that's how we use a stack. To use a stack, this part of code, we haven't seen here. Okay, in this case, this is a very simple case. We didn't see it. Okay. Okay, then how about let's take a look at the next one. Okay, second example. Let me first run the first example so that you get some idea. Okay, so I'm going to run the first example so that you will see. Can you see the running result?
Yes.
Oh, okay. I don't know if it's share the original one, share the. So right now, what you see is the running result. Is it? Okay, very good. And if you take a look, is it? So that's our original stack. The original stack, it's top down, as it is called the toString method. Output the stack, is it? And then it says, okay, after removing, oh, I think I got it wrong. I needed to, okay, yeah. Now I got, okay, so here is the original stack. Is the original stack, and then stack is full. So you try to add that 1,000. You remember, is it? And here it output that exception, array index out of exception. Is it that exception? Okay, then it shows the stack again. Is it? So we know this. And then next it says over here. It's going to remove the top of the clone. Is it? So we have 2 of this. Is it? The clone one, 99 is gone. But you see the original one, it's still here because it's itself. Is it didn't do remove here? Is it remove on the clone? Is it? So that's why over here it didn't do any impact. And the last part is just to try to show, okay, when stack is empty. If stack is empty, if you still try to do some top pop, it will throw exception, is it? And over here, it also show how do we reverse, is it? Okay, so over here, oh, I shouldn't, let's get back. Let's get back to the code, okay? So over here, we try to show is, if you recall, stack, one application for stack is stack can be used to reverse something, is it? So over here, it's reverse an array. So if you try to reverse some collection of data, then you can use a stack. Is it? Because it's last in, first out. Is it? So it's LIFO, okay, LIFO. And a lot of time, what we use a lot for stack is we can use this kind of combination. Okay, so it's like you while, suppose you call a stack, okay, while a stack is not empty, is it? So here we have, I forgot, is that empty function? Yeah, empty. As if it's not stack, is it? Then you can do like a stack dot top, is it? You do something with the top, is it? And then you do a stack dot pop. So this kind of combination, top and pop, together used a lot for all sorts of stack application, okay? So that's what I'm trying to explain this, okay? And a lot of time you use it, use a while loop while the stack is not empty, okay? Okay, so here is the basic concept. And next, we have a couple of minutes. Let me explain the concept of that. Then we are done today. So a second application, first application, we already discussed reverse and array, is it? Second stack application is to do number conversion. Okay, suppose you convert a decimal to binary. Decimal number we already know, is it like 109 something? Is it? Binary number means you only have 1 and 0, is it? And you have a lot of 1 and 0s, is it? That's called binary number, is it? Binary number because it's bit, is it? And that's what a computer does, is it? Okay, so here, suppose we want to do number conversion, we want to binary number conversion. So how do we do that? So here, let's take a look, example. Okay, suppose we want to do 13, is it 13? And how do we do it? And we can use stack concept. Okay, we can use stack, okay, to convert a decimal to binary. Okay, decimal to binary. Okay, so what we do is you first use this number, is it? You module 2. What you get? You get the remainder, is it? Remainder. And this remainder, you can, what we can do, you can push it to a stack, drop it to stack, is it? And then 13, you divide by 2, you take its integer part. Okay, so we are going to decrease the number. And then you are going to use 6 module 2. What do we get? We get 0. Then you push this 0 to stack. Okay, then you 6 divide by 2 in integer division, is it? And then we get what? We get 3, is it? Okay, then you use 3 module 2. What do we get? The remainder, we get 1, is it? And 3 divide by 2, what do we get? We get 1. Is it integer division? Okay, and then you are going to repeat this pattern again. Divide module 2, what do we get? We get 1. So you're going to get this one into stack, okay? And then what you're going to use 1 divide by 2. What do you get? You get 0. Is it? When you do divide by 2 as 0, then we stop here. So we are not going to continue our module and divide by 2 sequence anymore, is it? So you have this stack store either 1 or 0, is it? Because you module 2. Module 2, is it? You only have 2 cases, either 0 or 1, is it? And then you just pop out of the numbers. Is it what we get? We get 1, 1, 0, 1. Is it? So 1, 1, 0, 1 is binary number of 13. Is it? And here we can see, is it? You use a stack, you can do number conversion. Okay, you can do number conversion. Okay, so that's all of the information today, okay? And we discuss one application, okay? So tomorrow we can discuss more, okay? And this week I hope I can finish this chapter. Okay.